Students, good morning. Today I am going to discuss about the PVT behavior of pure fluids. PVT behavior of pure fluids. Before entering into this discussion, first what is meant by a pure fluid? Pure fluid is nothing but the system consists of only one component whose chemical composition is uniform throughout the system. It may exist either vapor or liquid or gas or even in supercritical fluids form. Okay, pure fluid is nothing but the system has only one component. Its chemical composition is uniform throughout the system. Next, PVT behavior, pressure, volume, temperature of the system. Now I am going to establish the relationship between pressure, volume and temperature of the system. In order to define the thermodynamic state of the system, two independent variables can be used to describe the thermodynamic state of the system. That means among the pressure, volume, temperature, any of the two independent parameters, independent properties can be used to define the thermodynamic state of the system. In my discussion, the system is equal to 1 k mole of water. 1 k mole of water. That means liquid water. Okay, 1 k mole of liquid water means its volume is 18.012 liters. Because the density of water is 1000 kg per meter cube or 1 kg per liter. From the density calculation, I can say that 1 k mole of water is 18.012 liter. So this is the molar volume, liter per mole or k mole, liter per k mole. So initially I know the volume of my system, volume is known, and I am going to perform the experiment or discussion at a temperature of 30 degrees Celsius. So temperature is also known. My experimentation was under the atmospheric condition, hence pressure is equal to 1 atmosphere. To discuss the thermodynamic state of the system, I wish to use a simple piston cylinder arrangement. Frictionless piston cylinder arrangement. This 1 k mole of water is confined in the frictionless piston cylinder arrangement. Clear? Right. To maintain the temperature as constant, first I am going to maintain the temperature as constant. Hence, a provision is made. That means perfect insulation outside of the piston cylinder arrangement. Temperature is fixed at a temperature of 30 degrees Celsius. I am going to perform this experiment. While you refer any standard textbook, we can get at a temperature of 30 degrees Celsius. The saturation pressure or saturation vapor pressure of water is 0.0419 atmosphere or 0.042 atmospheric pressure. This is the saturation pressure or vapor pressure of water at a temperature of 30 degrees Celsius. Clear? This data is also available in your. Clear? Right. Now I am going to change the pressure. Initially temperature is fixed. I am going to change the pressure of the system and I am going to monitor what about the variation of molar volume. Changes in molar volume with respect to pressure at constant temperature. Changes in molar volume with respect to pressure at constant temperature. Here for this A graphical representation is provided. V in x-axis, molar volume, P in y-axis, pressure. The initial condition are known. That means pressure is 1 atmosphere. 1 atmosphere. Volume is 18.012 liter per kmol. And temperature is 30 degrees Celsius. Clear? In this piston cylinder arrangement, a bolt threaded provision is there. While you rotate the piston, it may move in the upward direction or downward direction. Now, I am going to rotate the piston in order to move or lift the piston in the upward direction. That means expansion process. I am going to decrease the pressure and I am going to monitor what about the changes in molar volume of the liquid water. Clear? At point A, initial conditions are known. Right. Gradually, very smoothly lift the piston plate in the upward direction. The decrease in pressure is up to 0.042 atmosphere. At a 30 degrees Celsius, the saturation pressure of water is 0.042 atmosphere. Hence, I am going to decrease the pressure from 1 atmosphere to 0.042 atmosphere. So this is the state from A to B. The lift moves up to this level. This is completely vacuum space. Till the pressure reaches to a level of 0.042 atmosphere. During this reduction in pressure, the changes in liquid water is almost negligible or intangible because water is almost incompressible fluid. Incompressible fluid means changes in pressure to a moderate level does not cause to change its density. Clear? So this changes in volume is found to be negligible or nil. Right. Again, I am going to start from A to B. A, the initial state of liquid water is called subcooled liquid. Subcooled liquid or compressed liquid. Subcooled liquid means a liquid whose temperature is less than that of the saturation temperature of water at a specified pressure. Listen, now the temperature is 30 degrees Celsius. Saturation temperature of water is 100 degrees Celsius. Hence, the temperature is less than that of the saturation temperature of liquid at a specified pressure of 1 atmosphere. Hence, this liquid called it as subcooled liquid. Or you can call it as compressed liquid. Compressed liquid means at a temperature of 30 degrees Celsius, its saturation pressure is 0.042 atmosphere. But unfortunately, the system pressure is 1. Hence, I can say that the system pressure is higher than that of the saturation pressure of liquid water at a temperature of 30 degrees Celsius. Hence, it is a compressed form. So, it is called as compressed liquid. Okay. Now, from state A to state B, we reach the state B. Now, the pressure is equal to 0.042 atmosphere. That means liquid is in saturation pressure. The liquid now is in saturation pressure of 0.042 at a temperature of 30 degrees Celsius. This is state A to B. Once the state B is reached, vaporization begins. That means evaporation of water. Liquid water gets converted into water vapor. So this empty space is occupied by the water vapor. Clear? At point B, vaporization begins. The volume goes to increase rapidly from B to D. All of a sudden, all the liquid water gets completely converted into water vapor. The state is D. Clear? State B is a saturated liquid. B is a saturated liquid. Saturated liquid means a liquid whose temperature is equal to its saturation temperature, or a liquid whose pressure is equal to its saturation pressure at a specified temperature. Or I can say that the liquid is about to vaporize. In subcooled liquid is not about to vaporize. The saturated liquid means it is about to vaporize. It is about to vaporize. Point B is saturated vapor. Okay. Again, I am going to the definition once again. Point B is the saturated liquid. Saturated liquid means a liquid is in equilibrium with its own vapor at a specified temperature and pressure. Similarly, D, it is a saturated vapor. A vapor is in equilibrium with its own liquid at a specified temperature and pressure. This is about to vaporize, this is about to condense. Clear? Right. Coming to this section B to D, it is the horizontal portion. In this horizontal portion, the pressure as well as temperature is constant. There is no changes in pressure and temperature. Pressure and temperature along the horizontal line B to D is constant. Only thing is changes in volume. That means volume of vapor increases rapidly, volume of liquid decreases rapidly proportionally. Clear? B to D. Once D is reached, the entire volume of the cylinder occupied by the vapor. Okay, this is saturated vapor. Right. Along the horizontal line, any point provide the possible portion of vapor and liquid. In this section, vapor and liquid are in equilibrium conditions. Coexistence of vapor and liquid under equilibrium condition. During this or in between B to D, the phases are called as saturated phases. Saturated vapor, saturated liquid. Okay, they both are present in B to D. Clear? Right. Okay. From point D to E. At point D, all the liquid water is completely converted into vapor. Still, if you are decreasing the system pressure, the molar volume of the system goes to increase drastically. Molar volume of the system goes to increase drastically. Listen. When the pressure over the system is less than that of the saturation pressure of water, saturation pressure of the system at a specified temperature. Listen. Hereafter we are going to decrease the pressure still more. From point to D, I am going to discuss D to E in this section. When the system pressure or pressure over the system is decreased to a value less than that of the saturation pressure at a specified temperature, or if you are increasing the temperature than that of its saturation temperature, that means above 30 degrees Celsius. If you are increasing the temperature above the saturation temperature at a specified pressure, the vapor becomes saturated vapor. Vapor becomes saturated vapor. Hence, E is called as saturated vapor. Sorry, superheated vapor. Superheated vapor. Superheated vapor means its temperature is greater than that of its saturation temperature at a specified pressure, or its pressure is less than that of its saturation pressure at a specified temperature. Superheated form cannot be condensed without decreasing the temperature. Vapor and gas. Now we have a clear information regarding vapor and gas. Vapor means vapor can be converted into liquid in two ways. One is cooling, decreasing the temperature by maintaining pressure as constant, or compression, increasing the pressure by maintaining the temperature as constant. In both ways, vapor can be converted into liquid. Unfortunately, gas can be converted into liquid only by means of cooling process. That means decreasing temperature by maintaining pressure as constant. It cannot be compressed to convert liquid by increasing pressure at constant temperature. Clear? The discussion will continue within 1 minute. Okay. Now we are end our discussion. At point B, the volume of liquid water is 18.012 liter, this molar volume of the liquid. B to D, pressure and temperature remains constant. At D, entire liquid is completely converted into vapor. Now specific volume of vapor. At this condition, at a temperature of 30 degrees Celsius, pressure 0.04 to atmosphere or 0.08206. Specific volume of vapor V is equal to N R T divided by P. N is equal to 1 mole or K mole into R 0.08206 liter atmosphere divided by K mole degree Kelvin, and the temperature is 30 degree Celsius, 303 degree Kelvin. Pressure is 0.0419 or 2 atmosphere. The value becomes 593 liters. This is the volume of saturated vapor. Imagine that this is 18 liter, this is 593 liter. Always in your problem you can consider only volume of vapor, because the volume of liquid is intangible or assumed to be negligible. Okay. Now I am going to conduct the similar experiment in a elevated temperature. Temperature T is T2. The trend of isotherm A, B, D, E is similar. Again, there is two discontinuities in this isotherm. One is B, another one is D. Similarly, here also two discontinuities. B stands for saturated liquid, D stands for saturated vapor. In between, it is a mixture of vapor and liquid. When we increase the temperature, experimental temperature, the length of the horizontal portion goes to decrease. Again, if you are increasing the temperature, the trend is similar. Two discontinuities. Temperature is T3. Again, the length of the horizontal portion gets discontinued. Clear? The locus are connected. The locus are connected by a dome-shaped curve. This is the critical point. At this condition, there is no discontinuities. This locus of two phases, saturated liquid and saturated vapor, are connected by a dome-shaped curve. Area under this dome-shaped curve is a mixture of vapor and liquid. Left side of this region is called as liquid. Right side of this liquid is called as vapor. At a temperature to its critical condition or properties to its critical condition, that means when temperature is 647.3 degree Kelvin and pressure is 217.7 atmosphere, the critical volume will be 56 into 10 to the power of minus 6 meter cube per mole. This is the critical properties. Properties of substance at critical point C. Critical point C. At this point or at these conditions, there is no discontinuities. There is no discontinuities. Okay. If you beyond the critical condition, temperature and pressure is beyond the critical temperature and critical pressure, there is no distinction between vapor and liquid. No one can say this is a saturated liquid, this is the saturated vapor. It is not possible to distinguish vapor as well as liquid. Okay. Above the critical conditions, the vapor cannot be converted into liquid by either of the method, or the liquid cannot be vaporized in any means. Beyond the critical condition, critical temperature and pressure, vapor cannot be condensed by cooling or compression. Similarly, liquid can be vaporized by decreasing pressure. Both process is not possible. Clear? Thank you. This is the PVT behavior of a pure fluids. Pure fluids. In this discussion, we discussed or gained knowledge about the subcooled liquid or compressed liquid, saturated vapor, superheated vapor. Clear? Similarly, saturation temperature, saturation pressure. Saturation temperature means the fluid can change its phase. Saturation pressure means a fluid can change its phase. Clear? These information we discussed theoretically with the correct values of pressure, volume, temperature. Clear? Thank you.